The recent revelations about SpaceX's ambitious project known as Moonbase Alpha have sparked immense global interest, especially as humanity stands on the verge of returning to the lunar surface with far greater intent than during the Apollo era. SpaceX, under the visionary leadership of Elon Musk, has long been vocal about making humanity a multi-planetary species, and the unveiling of new concepts surrounding its lunar base project shows a remarkable leap forward. Unlike many speculative ideas of the past, this plan is firmly backed by the engineering progress being made with Starship, the fully reusable spacecraft designed to transport large payloads and human crews to the Moon, Mars, and beyond. The recent designs and insider details suggest that Moonbase Alpha is far more advanced than what competing programs from China and Russia currently envision, raising questions about how the balance of power in space exploration may shift in the coming decade. At the core of this development is Starship itself, which has been designed from the ground up to be the workhorse of lunar and interplanetary travel. The spacecraft's massive payload capacity, estimated at over 100 metric tons, allows it to carry not only astronauts but also the heavy infrastructure required to build a permanent presence on the Moon. This contrasts sharply with more limited spacecraft designed by traditional space agencies, where payload constraints often force missions to focus on minimal science equipment or short-term stays. With Starship, SpaceX proposes to deliver habitats, solar power arrays, communication systems, and even construction equipment directly to the lunar surface. This capability makes Moonbase Alpha not just a symbolic outpost, but a functional settlement capable of sustaining life and research for extended durations. The concept revealed outlines a modular structure for the base, with interconnected habitats designed to provide astronauts with protection from the harsh lunar environment. Radiation shielding is a primary concern, as the Moon lacks an atmosphere to block solar and cosmic rays. SpaceX engineers are exploring the use of regolith, the lunar soil itself, as a natural barrier, either through thick coverings or 3D printed walls constructed on site. This not only reduces reliance on Earth-supplied materials but also demonstrates an approach to in situ resource utilization, which is essential for making long-term extraterrestrial settlements viable. Within the base, life support systems would recycle air and water, while advanced hydroponic farms could grow food to reduce dependency on constant resupply missions. What truly sets this apart from China and Russia's current plans is the scale and pace at which SpaceX aims to proceed. China's lunar program is progressing steadily, with plans to build an international lunar research station sometime in the 2030s, likely in partnership with Russia. However, their approach remains cautious, relying on step-by-step robotic missions and limited human landings before committing to a permanent base. Russia, meanwhile, has struggled with setbacks in its space program, including failed lunar probes and reduced funding, casting doubt on its ability to independently deliver on promises of a moon base. In contrast, SpaceX's Starship is already in advanced stages of testing, and despite setbacks in early launches, each iteration has brought the company closer to achieving full orbital capability and precision landings. The sheer commercial momentum and private funding model gives SpaceX a distinct edge, as it can iterate faster and more boldly than traditional government programs. The unveiling of Moonbase Alpha also touches on geopolitics. The United States, through NASA's Artemis program, has already contracted SpaceX to develop a human landing system based on Starship. This partnership means that the first astronauts to return to the lunar surface as part of Artemis 3 are expected to do so in a modified Starship vehicle. Once this milestone is achieved, the infrastructure being tested for Moonbase Alpha could rapidly expand, potentially giving the US and its allies a significant lead in lunar colonization. The implications are vast, as control over lunar resources such as water ice, which can be converted into fuel, may become the cornerstone of future deep space missions. Of course, challenges remain. Building and maintaining a lunar base requires not just rockets, but also international cooperation, sustainable technology, and enormous financial investments. SpaceX, while revolutionary, still relies on collaboration with NASA for funding and legitimacy. Technical hurdles such as radiation protection, micrometeorite shielding, and reliable long-term power sources must be solved before Moonbase Alpha becomes a reality. Yet, the vision outlined demonstrates that these issues are being directly addressed, and the company's rapid pace of innovation makes it plausible that solutions will arrive sooner than skeptics expect. In essence, Moonbase Alpha represents more than just another space project, it is a symbol of humanity's next great frontier. Where Apollo was a race driven by Cold War rivalry, the new era of lunar exploration may be driven by private enterprise, global partnerships, and the pursuit of sustainability beyond Earth. SpaceX's design not only inspires imaginations but also sets a tangible roadmap for how we might live and work on another world. The comparison with China and Russia underscores how different approaches, commercial speed versus state-led caution, will shape the future of space dominance. If Moonbase Alpha succeeds, it could be remembered as the first true step in making humanity an interplanetary species, and the dawn of a new age in human history.